first day for learning the generative AI and large language model. So as maybe you are already familiar with the ChatGPT, and the term generative AI is getting trending nowadays. And in this presentation, I try to.
We are like elementary school students,
Okay, so
right? So you need to speak very slowly and very clearly.
okay, I will try to do that. Okay, so in this workshop, I will try to introduce the generative AI and large language model in the easy way and clear introduction. I try to avoid any mathematical term, because look at the mathematical term is make everything quite complicated. So let's begin with the first presentation. That the AI in general, that they try to inspire from human behavior to learn the old thing and create a new thing. So learning human behavior, what's that mean? So maybe you already know the Beatles, the one of a really famous band in England, or you already heard about Harry Potter, written by G.K. Rowling, really good novel story, or Albert Einstein with his work on theory of relatives. So what do we have in this common? The Beatles, J.K. Rowling, and Albert Einstein in their work. That their work, they are not just developed from the sky. Their thing is not come from the sky. They inherited from things on the past. For example, the Beatles. Their music is good, but they inherited from the rock and roll in the past, the blues and the classical music that already developed by lots and lots of bands before them. Or in writing and storytelling, when you read the Harry Potters, you read about the magical and monsters, everything. That thing is not come from J.K. Rowling by herself, but she inherited from the novel or the history or the mystery things from the past. That she combined everything and she started writing Harry Potter series. Or come from the theory of relative developed by Albert Einstein. That the theory of relative actually is not Albert Einstein. He was not thinking about that theory one day, but he has to read the Isaac Newton's classical mechanism and a lot of physical theory. Then he combined and he make his personal logic, and he developed the theory of relatives. So, in short, the human, they learn from existing knowledge and experience, and then they create something new based on their existing knowledge and experience. Then generative AI models, it follows the same way to create a new thing. For example, like you already see some, when you use ChatGPT or when you see something on the internet, new image, you just write something and they just draw a really cool image. So actually, it's possible by learning the pattern and structure from vast data set in the past. Let's see. This is a really famous example. So maybe you already see on the image on the internet. Sometimes you see a new face. You think that is a real human face, but actually that human is not exist at all. For example, like this person. Like this person. The face really look like human, but that person is not exist in this world. So how has that possible? The possible thing is that the scientists, they learn from real human image. For example, these image a bunch of data set that is from real human, and then they try to capture how the human face looks like. They have the eyes, they have the nose, they have the mouth, and they have the face. And then from a bunch of random noise, they put on another model and they try to create a face that might be look like the face that they learn. And then they come to a architecture called discrimination to compare whether their generated face looks similar to a real face or not. And then after this model, you have this one. You have this one. Oh, where's the mouse? Okay. You have this one. From a bunch of noise, become a real human face. So this one demonstrates the human behavior, that they learn something from the past, They learn the capture. They learn Okay, so I just say they start from noisy. So what is that meaning of that noisy? So let's see in this example. This is one classical application of generative AI. That is image generation. You have a bunch of real image. This is real image. That image to draw number 2, image to draw number 9, and image to draw number 8. Then your task is developing a model that generate a fake image. Remember, I generate a fake image, but that fake image must look like a real image. We want that. So how can this done? It's done by given the real image, they put on one model, and this model capture the pattern of this image. For example, number 2, they have this figure like this. Number 9 is have the figure like this. Or number 8, they have some circle figure like this, and then generate the image. And then from a noisy, actually, if you look at this matrix is not a number at all. You just see a bunch of noisy. But after they put on this generator model already capture the pattern of the real number from this one. So after they capture the pattern, they start generating a image that look like a number. Then they start have the process called discriminator. Discriminator is mean that they try to compare between the fake image and real image, and let's see if they similar or not. And they try to make it as similar as possible. After this model is finished, then you have a model called image generator. Then from here, you start generate a fake image, but look like real image. And DALL-E, the DALL-E model, maybe you already see this one.
Sorry. So the both of generator and discriminator, they are model. They are sort of a AI model.
Yeah, they are AI model. So the AI model similar. They just try to learn the pattern. In short, just similar. Try to learn the pattern and follow that pattern, generate something new, but follow that pattern. So, and another application of generative AI is image extension. If you have time, you can try this one, DALL-E model. It's very cool from OpenAI, and if I remember correct, it's free. And also Adobe Photoshop also apply this application. That the DALL-E model, they try to expand an image. For example, if you look at the Mona Lisa, the original Mona Lisa, it just have this one. Yeah, the thing that I marked on the red, that is the original Mona Lisa. The original is never had this. It's never had this before. But the DALL-E model, they try to train to expand the image. For the way they train is very simple. For example, you have the image. Maybe you have the human. I'm sorry, I'm not a good painting at all. And the sun something. And the way they learn is very simple. This is from the original image. Then they put to the AI model. And in this AI model, they try to steal this image, but they just show this human. They don't show the sun. And they try to teach this AI model, okay, from this image, please expand this image, which means adding the sun, adding the cloud, adding the bird, something. Please do that, follow that context. So from the original, they put on the AI model, but in this AI model, they just allow this AI model to see a part of that image, and then train the AI model to, okay, from that part of image, please generate the rest of the image. Then they apply that architecture to the Mona Lisa. Then from the Mona Lisa, the original Mona Lisa is here. But then they try to ask the DALL-E model, okay, from this texture, please add more context. Then this one start to happen. Okay, maybe the AI model, they think from this texture, maybe this look like a bridge, I guess. Maybe from this texture, okay, maybe it look like a church, then they add the church. Then you have something creative. From really easy, just learn the pattern, follow the pattern, and you can generate many things from that pattern you have learned.
So question.
Yep.
So generative AI, Gen AI comes from generator model. right?
Yeah, from generative model.
So we have a lot of models, but Gen AI comes from the generative model.
Yeah, technically. And if you want to understand the mathematical concept, the generative model developed by a probability and statistic function. Yeah, given this texture, what is the probability of that texture? And given that texture, what is the probability of another texture? They combine that and they generate that.
Big volume of the data,
Yeah.
past data.
The probability.
성우님 죄송한데 이거 뭐 재밌긴 한데 우리 하는 업무하고 연관이 없진 않겠지만 혹시 조금 벗어나면 조금 저는 제가 판단을 못하니까 조금 이렇게 뭐지 벗어나지 않게.
You want to explain generation and deep learning or machine learning just the same concept
Yeah.
with the LLM.
Yeah.
So 그러니까
Because
이게 지금 당장 아닐 수는 있는데 나중에 생각해 보면은 이게 이게 이렇구나. 이게 AI 산업 전체적으로 이런 식으로 진행되고 있구나라는 부분이 좀 이게 우리가 랜덤이나 우리가 할루시네이션 이런 부분이 왜 발생하는지 뭐 그런 측면에 대해서 알 수 있게 하는 개념이라서 그냥 일단 한번
당연히 뭐 지금 요 얘기는 아니고 이제 쭉 오늘 하다가 혹시 아무래도 학교에 좀 이렇게 아카데믹한 내용으로 많이 가면 저는 잘 판단을 못하니까 상무님이 좀 보시고 이거 조금 약간 이렇게 방향을 잡아주시면 좋겠거든요.
알겠습니다.
Okay.
So someone just mentioned about the hallucination that I suddenly remember. This is one way to explain the hallucination. That is when you use the LLM, the ChatGPT. Sometimes ChatGPT generate the answer, but you think that sound cool, but look like something's wrong in this answer. The answer may be incorrect. So this image is a illustrator of that, the meaning of hallucination. That you look in this image, you see maybe that is the painting, looks beautiful, but something's wrong. Look like this light is not connected to this one. The painting in general is not make sense. But it looks like the image, but in total it's not make sense. So because technically the generative, they just generate things based on the pattern that they have learned. So sometimes pattern is incorrect, leading to the image looks cool, but in general not make sense. Then another application that we might do, maybe, that is text to speech. That when the chatbot generate a text, maybe we can apply one module to convert that text into a voice and talk to the client. So that is another application of generative AI. That is from text to the speech.
Initially, STT starts from the customer call. Right?
Yeah, from the customer call.
And then maybe if we have a next phase, maybe we can directly speak to the model, directly speak to the customer, consumer. Maybe we need a text to speech.
Yeah, text to speech.
But this year we don't have those functions in this scope.
So text to speech, that technically that from the text and given the speech, they can generate a voice that person say that word, but actually they are not. For example, maybe I like Donald Trump, and I can ask Donald Trump to say something. Oh, Trump is really good. Actually, Donald Trump never say that, and maybe Donald Trump never know who I am. So, but I can do that by asking a AI model, learning the voice attributes such as pitch, phoneme, grapheme, spectrogram from the voice of the person. Yeah, they can learn from the spectrogram of that person, the way that person speaks, the voice, the phoneme. Then given the text, put to that voice, and then the can generate the sound that person, like Donald Trump, say this word. So right now, many people, they start developing that model nowadays, and ChatGPT also, they already implement this function. It's quite cool, sound real like human. And then now we start going with the language model. The generative AI also applied on the language model. One application of the language model is that sentence completion. When you study on high school, or like such as English, sometimes you have the word like fill in the blank. My name is a blank. Then you have to fill that word. Or today is a blah 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 day, and you have to add adjective on that blank. So the language model also follow that way to learn, that they try to fill in the blank. What does that mean? For example, the GPT-2, one of earliest GPT model, they start learning how to capture a writing style from a data set. So the way they learn is that first they start to learn to predict the next word based on the available words. For example, given the word the quick brown fox jump over, then blank 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 blank. Then you have to try to learn the model to predict which word filling the blank next. So after they learn, maybe they found that 80% is the must be in this one. Then let's assume that if the in this one, what is the next word come next? Then they add this word to this one, make a new word, the quick brown fox jump over the, then predict the next word. Maybe next one will be lazy. Put on the string and keep going, and then you have the complete sentence. So that is one of the earliest version of GPT model, learning to generate the next word. And then, so let's remind before we jump to the language model. The generative AI, they learn the pattern from the data set in order for generating samples. So if you develop something, it's really strongly dependent on the data set that you've learned. Then after you've learned and captured the pattern from the data set, you can start to apply to anything, a lot of things, such as in the language model, you can complete a model, such as fill in the blank. Or you can summarize a document. You give a bunch of documents, you give a sample of summarize, you teach the model how to summarize, and then you can start deploying the model into practice. Or question answering, you give the model the input, the sample input, and sample output of answer. Then the model can do the similar things like that. Or create poetry. All of this can be done as long as you have a suitable data set. So the problem is the data set. So before jumping to large language model or ChatGPT, let's talk about what is language model and how they have done in practice. So in the language model, let's try a word. Yes, sir.
The LLM, large language model, is a subset of the generator model, right?
Exactly. Yeah. So before that, let's play a word guessing games. If you see the question mark, what do you think? Which word we're filling next? What do you think?
Row.
Row. Yeah. Although this is the sentence, I didn't say where does this sentence come from, but looks like all of you think, it's just row. I never say that. I never say, but you think that. So it's really cool. So that is one way to illustrate how large language model work. They work from the data set and try to predict based on the sentence that they have learned. And from on the early development of language model, I believe around 1980s or 1990s, that they try to predict the next word given a sentence. They try to learn fill in the blank. But in that way, they just simply follow the probability rules, very, very basic level. So in the way of they try to learn fill in the blank, they are not learned by just filling the last word. Maybe they try to learn filling the middle word, or they try to learn how to predict the earliest word, every word possible. And then, but at that time, the quality is not so good because we're using the probability rules by hand, so it's based on how the researcher defined the rules. And then the machine learning come to play. Around 1990s and the year of 2000, machine learning comes to play. And after that, a lot of function, a lot of application that the language model that can do. The first function that we can think is the sentimental classification. You have a new movies, you have a new books, and you want to know whether the customer like this books or like this movie or not. Then luckily you have the lots of function to do, such as LSTM. The LSTM, you can think similar is that you give a string. For example, someone say, "Oh, this movie, best movie ever," and you try to understand whether this function is, whether this sentence is a positive or negative. You put every character into LSTM, and LSTM is try to combine and apply some mathematical function, and they decide, okay, this sentence must be positive. Or someone can say, "Oh, this is terrible movie." They can think, okay, this one is negative word. That is one application. The second application is the name entity recognition. In this word, for example, when a user sends a really long bunch of text, sometimes you have to identify what is the topic of this text, what is the folder of this text, what is the date of this text. Someone can say, hey, Tron, tomorrow, let's do another presentation. So you have to identify what is tomorrow and what is the problem. Presentation. So name entity recognition, their task is identify things like that. Given
We discussed about this yesterday, right?
Yeah,
Entity
analysis, number 4. So you can see that the author can give a bunch of really big text, lots of text, and they store a lot of information. But somehow you need to find a good information in this text. Then you can apply a name entity recognition. With name entity recognition, they can identify People magazine. This is the publisher. They can identify navy, that is the color, light blue, that's also the color. So which means that in the application, if someone can search what is People magazine, you can take the word People magazine and you apply name entity recognition and test on your database and take everything that contains the word People magazine, that is a publisher, take it out. Or in this, and this is another application, when we say about Barack Hussein Obama, that is a person, and the born in the United States. And so maybe you can, in the practical, someone can say, who is the president of the United States that was born in 1961? That is the input. From that input, they have the word United States. They have the word 1961. And so you can say, okay, United States, 1961, you take the sentence out. Barack Hussein Obama. That is another application of name entities. It's really helpful on searching. Another application is the text classification. The text classification is that you can think that you have a lot of domain and you have received a lot of text from a customer. But sometimes the customer wants to supervise. The customer wants to seek for help. Or the customer is claiming something. Or the customer wants to report something. There are many categories that possible given one input. So the text classification problem will help you to do that. Given an input, you try to classify what is the customer want to do. So this is the general architecture, real AI architecture. You have a sentence, that is the input. You also have another sentence, like they say I something proud, like maybe I make you proud something, or my pride something place. Then you put on the generative AI model. The BERT is quite famous, one of the most famous generative AI model. Then they start to do some technical stuff, such as token embedding. The token embedding, right now I can say, is kind of convert a string to a number, because we have the calculation, so you have the tool to convert string to a number. So from this number, you put on the huge architecture to make some calculation. And after start on calculation, you start to do the classifier. Okay, looks like this text belongs to contradiction, or it's just neutral, or it's belong to entailments. So I just mentioned the word token embedding, and maybe if you study about a large language model, you heard a word token many times. So what does that mean?
I have a question.
Yes.
About that. I know the word token and the position token is very important.
Yeah.
But how about the segment token? It is a kind of tag or labeling something.
You mean this one?
Yeah.
The segment token means that to understand the beginning of the token and the end of the token. Because at the in the traditional, if you don't have this one, how to identify the ending, sometimes the text is just keep generating and keep generating. It's never stop. So by having the segment token, you know that the model cannot at that time we should stop. This is the problem the Google Gemini happened before. That when a user send an input, the Google Gemini just keep generating the output. They never stop. They just keep generating. So that is the error. So they have to retrain the model to not understand when we will stop the sentence. Yeah, kind of take a technical technique.
What I heard about token, if we ask, if we prompt in Korean, it spend more token than English, so it costs more than English speaker sort of a news.
Yeah, usually.
That token and this token is same?
It's same. Actually, yeah, same technique. So what's that mean? Yes, sir.
Okay.
Yeah. So what is the meaning of the token? The token is similar. That is the piece of text. The piece of text, there might be a word, a subword, or a character. And because like I said, given a string, you have to convert that string to a number. And from that number, you do the calculation. So at that time, the researcher think, how can we convert a string to a number? So one way is very easy. You give it the word, this is tokenizing, just separate that. This is tokenizing. You have 3 words. And you start encoding, this is a word number 1, is a word number 2, tokenizing is a word number 3. And you convert that and you put on the model. But there's one problem come. What happens if someone have the typos? For example, instead of writing tokenizing, you have the typo, you forgot the G. The word tokenizing it never exists in the English alphabet. So how can we tokenize that? So at that time, the scientists must develop a new model to learn how to make a tokenizing. So they have to learn. So the way they learn is that given a string, they start to splitting the string. Maybe they split in the character level. Maybe they split in the word level. This is tokenizing. Or maybe they split in the subword level. For example, the tokenizing, they will split between token and izing. And for example, if the typo happen, well, just simply eliminate that. Then at least you have the word token. But if you follow the word level and you have the typos, you just have the this is. You cannot solve the tokenizing, which means that you will lose a lot of information. So in the Korean, so it's the way of how to learn the subword really strongly depend on the language that you use. In Korean, you have to use Hangul. So we have a tokenized model for Hangul. English, they follow the alphabet. Then we have the token model for the alphabet. So that's why it leads to the reason why it leads to the English the Korean token costs more than the English token is because of this problem. The behavior is different. So that is a really basic concept of token. So now I think we can start jumping into the large language model. So what is the large language model? The large language model, literally, that is a language model, but it's large. Simple. It's very simple. We have a lot of small models such as Elmo, GPT-1, GPT-2 from Google or LSTM. This is a very small model, and they will train to learn like fill in the blank, word generation, and then then around maybe 2020 or 2019, lots of authors think is that how about we expand the input, like with in the past, the small model, the number of input is very small. Maybe you just have hundreds of words or 1,000 of words, and the number of output is also small. Maybe the number of output just 2 or 3 or 10 or 100. And one of the things that this is impractical because sometimes the user can write really long text, maybe thousands of texts, but you have thousands of words, but your input is just receive hundreds of words. So we have to expand the number of input and the number of output. But if you expand the number of input and the number of output, it will lead to the number of parameters, calculation parameters is also increased. And it leads to the term called large language model. The language model is very large. Computational complexity consumption contain lots of parameters.
So if there are more than 100 billion parameters,
Yeah,
we can say
large language model.
LLM.
Yeah. So that is the meaning of LLM. Technically, it's just a model, but just large. So how the large language model was developed? By understanding that, it will help you a lot, such as how you use the ChatGPT, how you use the prompt engineering. It will depend on how the large language model was training. Because like I say, the generative AI, they follow the pattern to generate the output. So if you understand the pattern of GPT, then you can use that GPT very conveniently. So technically, the GPT model, they contain 4 stages to do: pre-training, supervised fine-tuning, rewarding, and reinforcement learning. In the pre-training, you can see that actually the pre-training, their task is just simply predict the next word, fill in the blank. They start from really basis problem of large language model is a word token, next word token prediction. They for making things useful, they download a lots of data set from the internet, maybe terabyte. I will show the data set on the next slide. And then from this data set, they apply the language modeling to predict the next token based on the previous text. They just learn how to do that. And then they try to develop the word guessing model as best as possible. And they have to generate the thing called base model. And from that base model, they will develop many things. And you can see that just only for the model, for the next token prediction, they cost thousands of GPUs just for training that task. And it takes months of training to finish the base model. So that is the way GPT or Llama or Palm, they finish. And after you have that model, you can predict the next word conveniently. Then after that, you can start fine-tuning this model, which means that instead of just predict the new token based on the previous token, the new task will be, you will do the same, but the input is something have like a fixed form called prompting, and the output will be the response. In this stage, they just predict randomly. Your internet have something, they will predict the other thing. No fixing, no editing. But in this supervised fine-tuning, they will start editing the process. The input will be some meaningful technique, and the response will be meaningful response. No more random anymore. Then they still apply this language modeling to predict the next word. And then they have the output. So at this stage, the GPT can looks like real assistant, virtual assistant. At that time, I remember around 2019 or 2020, at that time, the newspaper, they start talking about GPT model that they can answer based on the input. That is the process. It's just word guessing, but they modifying the input and output. It takes around hundreds of GPUs and around days of training. So you can see that in the base model, they take months of training. But after the base model is finished, they fine-tune, and it just costs days of training. The time is reduced really quickly. And then after this, they apply this model to fine-tuning the output again. Because the generative AI, like I said, they can generate many output given one single input. One single input generate many output. So in this stage, they start to modify a little bit that from many output, which output is the best for the model. So they start study to make a comparison. They required some human to compare between the input and the output, whether this pair is low quality or high quality. It looks like the text classification behavior. So given the input, output, classify whether this input, output is the bad or good quality.
Is it something similar with the LLHF?
LSTM.
LSTM?
Yeah, quite similar, but they don't use LSTM model. LSTM is the name of the model.
Yeah, it's a reward model by human feedback.
Yep.
Right?
Yeah, kind of. And then in the final stage, the reinforcement learning, then actually it's still this process, but they try to check the scoring. They start scoring. So sometimes when you use ChatGPT, you can see that ChatGPT generates 2 answers instead of 1 answer, and they allow you to select 1 out of 2. Maybe they think 2 answers is also good, so just let the customer select that. So here are the data set. That the most common data set is the common crawl. It costs around 3.3 terabyte. The common crawl, if I remember, is that someone crawl everything from the internet, and they forming this common crawl. And they also have the data set from GitHub, Wikipedia, Archive, or Stack Exchange. And if I remember correctly, in these data sets, 60% of this data set is English, 60%. And the rest is Korean, Vietnamese, Chinese, Russia, but mostly is the English. So if you try to use ChatGPT, you will see the different behavior between English and Korean. Same question, but if you ask in English, they generate a different output. But if you ask in Korean, they generate different output. So when we develop the Dfocus GPT, this behavior also happened. That we try to answer by writing Korean, but the answer looks really weird. But when we change to English, the answer is very good. Because, well, they learn the English style more than Korean, so the quality also different.
That makes sense. The question I asked, why LLMs spend more token for Korean, prompting than English?
Because it's based on how the word is, how the word is split into the token. For example, one English word, like I say, for example, this is funny. They can split it into 3 words. This is and funny.
3 tokens.
Yeah, 3 tokens. But in Korean, because from the Korean word, they are from the Hangul, so they have to convert to Unicode. Right. So that Unicode from Korean is different than Unicode from English. So the cost will be different, but looks like longer.
The difference comes from the how I can say
the encoding from.
제가 한번 잠깐 설명을 좀 드릴게요. 우리 사전이 있으면은 사전이 작은 사전이 있고 큰 사전이 있는데 그 LLM도 자기 자신만의 사전, 벡터 공간 차원이 있거든요. 그래서 어떤
이런 그게 벡터 DB인 거예요? 다른 거예요?
그래서 우리가 일단은 벡터 그 토큰에 대한 사전, 그것들을 예를 들어서 뭐 GPT 5만 개를 담을 수 있다. 사전에 5만 개가 숫자로 1번부터 5만 번이라고 하면은 그러면은 뭐 들어갈 수 있는 단어가 한계가 있어서 영어들은 다 들어가는데 한국어들은 가나다라 뭐 이 정도만 들어가서 전부 다 쪼개져 버립니다. 예를 들어서 아버지, 어머니 이것들을 아버지 하나에다가 숫자 하나를 매핑을 시켜준 게 아니라 아 하나, 버 하나, 지 하나 그렇게 돼서 이게 토큰 수가 많아지고 계산할 때도 의미 단위로 잘 계산이 안 되고 사실 근데 그런 식으로 캐릭터 단위로 쪼개졌음에도 불구하고 답변이 잘 나오는 게 신기한 거고 최근에 오픈 AI 마이크로소프트 이 측에서 한국어 부분을 좀 많이 추가를 했어요. 그래서 토큰 많이 사용되고 그렇지는 않은 것 같아요.
That model to work on America. Yeah, things may different. So
it's like we are going to develop a Gen AI project based on OpenAI in Korean.
Yeah.
Like we are going to develop English project using
Korean,
which was based in Korea. So
yeah.
Sort of, that's
so, which means that I have also actually that is a challenge, but sometimes it's not that bad, because when me and Lee Jong-ho work with ChatGPT, ChatGPT is 60% in English, but it's also work quite well in Korean, but it will also make us lots of challenge. Sometimes technical is wrong, output is wrong. If they train in English, oh, so good. But if they train in Korean, we need to take it carefully.
Okay.
So the ChatGPT also, given the raw text, they will try to learn how to convert the raw text into token. The method that I said about tokenizing, they call byte pair encoding. That is the algorithm to split the text into token. Like you can see is that it's not always split at the space, white space. They never split that like that. Sometimes they have maybe, do they have the overlapping? Okay, because like sometimes they slip it on like this.
Tokenized.
Yeah, token and NS.
Here.
Yeah. Okay, here. Like from tokenized, but they don't take the whole word, but they split. Because the way why they do that, because they want to avoid the typos. Sometimes you type and you have the typos. Tokenized, but maybe you forgot the ED for typos. But thanks to the byte pair encoding, even though you have the typos, they can still convert the token into number. And they can make a calculation. So that's why when you use the ChatGPT and you make a typos, the ChatGPT still understand what you say, thanks to this tokenized technique. Okay, we have a two example of models. This slide is quite old, GPT-3 2020. And if you want to use something new, you can use the Llama. Llama is the model that they public on the internet. But GPT-3, they don't public on the internet because of their secret. So in their token model, they have 50,000 vocabulary size. Like you can see, this is the one of the word in the vocabulary size. So they have in total 50,000 vocabulary size. And the context length is 2048. What is the meaning of that? You remember the word guessing games that I say? That you have lots of text and you try to fill in the blank. So the 2000 and 2000 context length means that you have 2000 blank and you have some input. Your task is filling the blank of the others, but the total is 2000. So that is the meaning of 2000 context length, which means if your input costs more word, then your output got less word, and vice versa. So that is one properties of GPT-3. So when I developed the first version of Dfocus GPT, these things also happen. That I put a lot of text into the input, but the output is very short. But then I look at the document that I found out because of the context length. So I try to reduce the number of input, then the output generate a lot of text. And the number of parameters is quite large, 175 billion, and they train on 300 billion tokens. And this is just the configuration, how they train configuration. This is quite of AI concept. And they training around 10,000 V100 GPUs. If I remember the V100 GPUs, the price is around maybe 10 million for one GPUs. 10 million for one GPUs.
It's a higher model than
one of the highest model. So it's got around 1,000 and 10,000 GPUs, and so they say quite servers, and take nearly a month of training and cost millions of dollars just for training the GPT-3. Then the Llama model is from Meta. They also follow that way. The vocabulary size is less than the GPT-3. The context length is similar. The parameter is smaller, and then this is the configuration. They also train on model. They cost around 2,000 GPUs, maybe slightly less than this one. A100, I don't know about the price, but it's quite expensive. Although the day is smaller, but at least they cost around 5 million just for training that. So that is the difficult. If Dfocus want to develop the large language model, we need lots of GPUs, lots of money, and the time for training, and also the human for training. Like you see the training phase, step by step, we have to prepare carefully. So this is how the ChatGPT, they generate the text. that maybe if you don't familiar with the term training batch, it's okay. It means that calculating synchronously, simultaneously. You have 1, 2, 3, 4 input. The model calculate 4 input same times. You can understand like that. So this is the input. As you say that we have the text, now it converts to token. So we don't show the text anymore. We just show the number. And your task is that given this input, you try to predict and estimate the suitable token for the next output. Then, for example, you have the list of prediction. This is probability. And you pick, let's pick the highest. Then this is the word that you predict and you fill in the blank. Then you have a new sentence. Then from this sentence, you try to predict the next word. And then you have this new sentence, you try to predict the next word, next word, next word, and you finish. And if in practically they have one token for stopping, like I said with each of harmony, you have the token for stopping. Like for example, token number 1. So if you see and after generating they reach the word number 1, they will say, okay, stop generating anymore. This is the complete sentence. And the base model, they simply is just word guessing. So how the word guessing game become a useful task? Here's what they do. You imagine this is the input. You give in the text. Maybe you already have the going for English testing, right? Sometimes you work on English testing on the high school. They give you a paragraph, and then they ask some question. Okay, look at the paragraph and answer the question. You learn from the high school. So in ChatGPT, they testing that phrase. We give the ChatGPT a long paragraph, and you give the question. How old is Catherine? And the answer. Then another question. Where does she live? Then GPT-2, technically they are trying to fill in the blank, but luckily they fill in the answer. Like where does she live? Maybe it's quite long. Maybe Sweden, for example, Sweden. So where does she live? When you put on the ChatGPT, suddenly the answer is word Sweden. So that is the way the GPT-2 from a word guessing game is trick is to performing a task that completing the document, that they can answer the document. So from this behavior, the GPT-2 kick off the error of prompting over fine-tuning. What's the meaning of prompting over fine-tuning? The prompting over fine-tuning is that instead of fine-tune on the new data set, it's cost millions of dollars and it costs millions of, and it costs lots of GPUs. You just try to adjust the input to get the output and done. Finish the task. But they have to say that the base model so far, they are not assistant. Sometimes they can generate the good answer, but sometimes they generate a bad answer. For example, you have the word, write a poem about bread and cheese. That is the comment, and you expect the output is the poem. But if you put on the base model, because that is a word guessing game, so they just generate a bunch of nonsense words that they're not the poem anymore. But if you trick a little bit, your input, write a poem about bread and cheese, but still in the input, you add this sentence. Here is the poem about bread and cheese. Then you click enter and wait for the output. The output suddenly become a poem. So that is the really cool thing, that it can be tricked into performing tasks by writing a suitable input, by adjusting the input. And right now we are calling the prompt engineering, adjusting the input to generate a good output. So here is another application. This is a maybe I think I will circle back to this slide later because I need to add some more information. So literally, yes.
How many remain?
We are in slide 23 and we have 47 slides in total, which means we are half in the way.
Maybe with some break time. Yeah.
Okay, so we have maybe 10 minutes break.
Yes, please.
Yeah, I need some water.
잠깐 쉬었다가 정리를
So like I said, the LLM, that is a word guessing games. The word guessing, given the output, try to predict the next word and complete a sentence. And literally, they train for text completion. And like you have seen in this slide, by adjusting the input, you can have the good output that have meaningful. So OpenAI, they see this behavior and they retrain the model again by adjusting, remodifying the dataset into a format called prompt and response. So specifically, you can see the prompt is the input and the response, that is the output. So because the generative AI behavior depend on the dataset, so they fix the data, they change the dataset behavior to follow this capture. So they relearn the LLM that given the prompt, try to learn the response. So then in practice, you can see that the input will be quite really long like this. This is just example, so that's why you see it's very short. But in practice, sometimes the input is very long. It contains a lot of command, such as I want you to be is helpful, trustful, harmless, something. So in practice,
The title says labeling guidance. Can you go up?
yeah, okay,
It's a labeling instructions.
yep,
I feel like it's a prompting instructions.
yeah, kind of.
Is it?
Quite similar. There is a section of prompting, but in this prompt, they try to instruct behavior of the model. So just answer helpful, trustful, and harmless.
아 여기도
그러니까 이런 걸
라벨링을
레이블링이라고
쓰네.
하네.
그죠?
약간 이게 프롬프팅이랑 비슷한데. 그죠?
There are
The
many.
label is like more helpful or truthful. It is a label.
Actually, there are many ways for explanation. In this test, the label is for training ChatGPT model.
Okay. It's for the training LLM. So
Yeah.
Okay.
So behavior is will be different. So they modify the dataset into the prompt and response format and expect that giving the input, they will have the good output like you are using the LLM right now. So when we develop a large language model, including Gaussian and ChatGPT, there are something that we will take note. This is the technical information. That is the token limitation. That is the thing that by default in ChatGPT. The ChatGPT 3.5, the content window is around 16,000. You can understand that the input, first I have to clarify that they have two sections. Number one, this is the input. Number two, this is the output. So for the input string, you have maximum 16,000 for the input only. And the number of output is around 4,000. So maybe you can ask ChatGPT, generate 5,000 words, 6,000 words, but maximum they just only generate 4,000. So that is a thing you have to take note. When I work with the Canvas GPT and develop the Canvas GPT information, we have lots of information. And Ihonchun Samunim say that I want to display all of this information, but the total information is around 5,000 and 6,000, and ChatGPT cannot handle that. So I have to adjust and remodify the behavior of ChatGPT. So we have to take note that regardless how many tokens I use in the input sentence, maximum 16K, the output is only kept at 4,000 tokens. The ChatGPT 4 Turbo, you have to pay money for using this version. The number of input is longer, 106 and 28,000 tokens, but the output also 4,000K. So with ChatGPT 4, you can have more input, but you just only have 4,000 output.
Why they don't increase the output?
I have the feeling that by increasing the output, the training will be more difficult, because like word guessing game, you have to manage your output and make sure your output makes sense, make sure your output have the stop sequence, so it makes things difficult.
They're selfish.
Kind of.
They would like to receive more than give.
And you know, maybe because they develop and they need, and we need them, so we have to follow the rules.
But recently, latest model increased that maximum.
Not yet. The maximum is still 4,000. I don't know how about GPT-5, but GPT-4 is just 4,000.
As I know, experienced about the GPT-4. Now I use GPT-4 only and then GPT-4. It generate more than 4,000 token in my thinking.
Oh, really? So you can check, because when I read on OpenAI document, they just said the maximum is 4,000. I don't know if they already changed that behavior or not.
GPT likes him more than you.
Because in talk about the input output, when you use GPT, you have to pay money for them, but the cost of inputs and the cost of output is different. The cost of input is cheaper than the cost of output. So if you generate more output, you will pay more. Yeah. So, and in the ChatGPT, you have many parameters to adjust. You can, if you use the ChatGPT API, sometimes you heard about the term temperature, top. And when we develop LLM model, we have to also adjust this information, temperature, top K, top P. So what does that mean? Let's remind. Language model, they select a next token based on previous token. So the question is, how do we select? Maybe just select the highest probability, or maybe just select randomly. So in fact, we want the generative AI to be creative, sometimes conservative, depend on the situation. If you write a novel, you want ChatGPT to generate creative sentence, which means that rare case, maybe some sentences never rarely happen. But if you want the ChatGPT to answer the question, you want the answer must be conservative and persist. So it will depend on the way we want to use. So that's why they developed 3 parameters: temperature, top K, and top P.
Okay.
So let's go to detail. The top P is mean that they will select the top word that having a cumulative distribution value larger than or equal to P. So what does that mean? Let's say we set P is 0.6. And the maximum probability, the probability of the word 3 is 39. The probability of the word N is 16. And the probability of the 2 is 7%. But if we sum up all of this, is maybe around 20. Yeah. If you just sum 1 or 2, maybe just around 45 or 50 something, is smaller than 0.6. But if you sum 0, 2, 1, 2, then yeah, you have the total, the cumulative distribution is around 0.7, which is already larger than 0.6. So they will select 3 and 2 as the candidate, just candidate. They not make the final decision yet, just candidate. And the top K? The top K, they will select keywords that having the highest probability value, which means that if K is 2, then they will select 3 and, because you're allowed to select 2. And after that, we have the final decision. Now we have the candidate. This is the one candidate. If you want to use top K, this is your candidate. It depends on what to use, top P or top K. Then you start adjusting temperature to select the final decision. So after you have let's say 1, 2, 3, 4, 5. So let's pick 1, 2, 3, 4, 5. For example, this is your candidate. So given 5 words, you have to select 1 word to fill in the blank. So how can you select? It will depend on the temperature T. This T belongs to 0 or 1. The purpose of that, they try to scaling the probability. So what does that mean? If I set up a smaller T, for example 0.1 or 0.05, immediately they will scale all 5 probability into this diagram, which means that the probability of the large word, the probability will change. Maybe this is 0.7. Some small word, they will be extremely small. It's just kind of adjusting and scaling the probability. But if you select a larger t, maybe around 0.5, the probability, like now you can see, is quite flattened a bit. So from this probability, they will write a function to select one word randomly. Remember, although they're scaling the probability, but the word will select randomly. But that randomly will be depend on the probability value, which means that if this probability is 70%, then out of 100 times random taken, there will be 70 times this word will be taken, and similar meaning of this word. So if you set up a temperature very small, then the word that have high probability will have the highest chance to be selected. But if you set the t is large, then there might be chance that some rare case word have small probability, maybe have the high chance to be selected. So it will be depend on the way you set up the value of temperature. So if you want to write a novel and you want to make it more creative, more new word, then let's set up a larger t. And if you want to develop a conserve and process LLM, then let's set up a smaller t. So in our Dfocus GPT, because our Dfocus GPT is question and answer, so we have to make sure the answer must be correct. So that's why we set up really small value, just around 0.1. Yeah, okay, so here is just remind, by set up the large t, then smaller probability word will have a higher chance of being selected, like this one. But if you set up smaller t, then larger probability words are likely to be selected, like this one. So depend on the user case.
This parameter is for the entire model, or what level we are adjusting this parameter?
Is we are adjusting the parameter in the model output.
So,
which means that the model is fixed. We don't train the model anymore. We just give the input and receive the output. This adjustment will be adjust the model how to select the word to produce the output.
응답을 얻어낼 때 저희가 질문을 할 때 주문처럼 항상 이렇게 파라미터들을 지정을 할 수가 있는데 매 요청마다 근데 이제 템퍼리처가 뭐 낮은 경우에는 상당히 조금 폐쇄적이고 좀 정답에 가까운 Q&A 이제 에이전트가 돼야 된다고 하면 일반적으로 템퍼리처를 좀 낮게 해서 저희가 요청을 하고요. 근데 보시면 이제 높게 한다는 경우가 이제 어떻게 보면은 템퍼리처 높았을 때 정확하지 않은 답변이 나올 수도 있다는 건데 그럼 이게 어디에 쓰이냐면 이제 창작 영역 쪽에서 많이 쓰이는
크리에이티브. 그러니까 궁금한 부분은 그러면 프롬프트를 날릴 때마다 이런 걸 조정을 하면서 할 수 있는 거예요?
다 할 수 있습니다. 그래서 다 만들어진 모델에 매번 요청할 때마다 주문을 넣는 방식인데 그때 템퍼리처를 조정할 수가 있다라고 생각하시면 됩니다.
Yeah. So one thing we noticed when we developed the project is that we have to remember. This is a sentence that maybe you know that during 2 hours I repeat many times that AI model or generative AI model depend on the data set that they learn. So AI model, they learn to recognize pattern and structure in the data before generating the output. So if the data has some problem, the output also has some problem. And Google Gemini got that. So 1 or 2 months ago, someone tests on Google Gemini. The Google Gemini, they can generate a new image. But if they say that, let's generate an image of American women, American heroes, American families, they just generate the black person. They never generate the white. But if someone say the word, let's generate a white happy family, the Gemini said, sorry, I cannot do that. It will become racist. So it's make the community crazy. What happened with the Gemini? So when they dig and they found out and they say that in the training phase and the data set, the Google Gemini already adjust that make everything biased toward the black community. So let's remind the quality of ChatGPT output or any other large language model output will be depend on several factors. Number one, the model structure itself, such as LSTM, if you heard on the internet, LSTM, BERT or transformer, it depends on the architecture itself. The second factor, that is the quality of the training data. If we have the better and more relevant training data, then the output will have the higher quality. And If the dataset is predominantly in English, such as ChatGPT, then in this input will highly likely produce better output. So if you use ChatGPT, and mostly I guess you use in Korean, but sometimes you see that Korean output is bad, try changing to English. Sometimes English is better. And then the third factor is that the input composition, is that how you write the input, how you declare the input will greatly influence the behavior of the output quality. So that is something you have to take note. Yeah, prompt engineering. So it will lead to another section. It's called prompt engineering. The way we behave the input will lead to the output quality. So like I said, I present, by the way we're writing the input, sometimes we get the really good result in the output. Of course, sometimes we have to adjust the temperature, top P, top K, but the input will play a really important role. So ChatGPT or any generative AI, they can produce multiple output from the same input. And from those multiple output, some output may be high quality, but others may not meet the desired standard for us. So of course we want to have a high quality. We don't want to have a nonsense output. So by prompt engineering, we can craft the input text to guide the model in generate the desired output. So we can see from the practice, because actually they train from internet. Maybe you know the size Stack Overflow, right? If you have some question, you usually go to Stack Overflow and you make some question. That in Stack Overflow, sometimes some user want to ask, I try to use SQL. I do the insert, but I have some error. What happened? Can you solve? Then the output, usually someone say, let's try this function. This is a standard. It works for this database. Then this type of architecture, input, output, we also mimicking on the prompt engineering. The prompt like here, you can see that it's similar to the input. And the response will be the answer from the user. Then from that behavior, we have many techniques, prompt engineering technique. The first technique we call zero-shot prompting, that we simply write a input prompt with a leading phase and so for example, like you say that write a poem for bread and cheese. Here is the problem about bread and cheese. You take that as the input, then ChatGPT will lead to the output. So we will take that leading phase, here is the poem, and follow that way. For example, you have the word classify the text into neutral, or negative, or positive. The text is this one, and then you have this word. The word sentiment is the leading phase, and you will expect ChatGPT will fill in the blank. Then ChatGPT will fill in the blank, the word neutral. So from the large language model, it turned out to become a text classification model. That is called zero-shot prompting. The next approach is the few-shot prompting.